All right, so this is lecture 4 on chapter 8, dealing with dynamic addressing. In this video, I'm going to, and actually the next couple, we're going to be talking about addressing 6, version 6, and there's several ways that um, DHCP is handled. One of them is just like in version 4, addressing 4, where the router handles all of it. So let's get into it, and I'll show you what's available. So DHCP v6, get tongue-tied on all the words there, actually is it's going to come in two flavors, two different ways that this occurs in version 6. The first of which is DHCP is adapted to IPv6. So that implies there's a server in the transactions. So you can get underneath that statement from DHCP, Dynamic Host Control Programming Protocol. We know from what we just went through with IPv4 that there's a server involved in handing out the addresses. The server has a block of addresses. It can reserve some of them, and it gets to hand out the others where it wants. Well, that could be one of the options when you get to version 4 addressing. There is a lot of address space in version 6, so we have other possibilities. One is called this stateless slack. It's a stateless auto configuration term. So that means there's no server involved. It's still dynamic addressing, but there's no server involvement. So it's a little confusing when we hear stateless, and then we'll hear the opposite is stateful. So that word can be a bit confusing because something serves IP addresses. Something is making IP addresses. We're going to be talking about that. So it comes in two flavors, but it can operate in any of three setups. Strictly stateless. It can operate as stateful, which is the opposite, or it can operate as a combination of the two. Principally, we're going to be looking at these first two, and then the combo is going to be available for that. You'll see. All right, so stateless addressing, auto configuration, that's where the slack, stateless address auto configuration. So here you've got the basic setup of the client and the router. The switch is in the middle. This would be your simplest setup. We've done this many times, both in hardware and on packet tracer. Okay, so stateless auto configuration uses the ICMP rather than the discover message. Now you may want to go back and look, even from last semester, at ICMP messages. That's basically a messaging capability. We tracked this on Wireshark back in the day, so you can actually see these messages come across. They're a simple message protocol that can be of various lengths and sizes. You can stack a lot of information in there. It's a little different than the discover message, which is the type used in address version 4, where the client sends out a discover and the router who owns all the addresses responds to that. Okay, that's not happening here. Here there's a router solicitation that goes on from the client, and it's a multicast. Right? I'm not aiming at one particular router. It's a multicast. So, and he's asking for not an address, he's asking for, the client he's asking for an advertisement from the router. Okay, so the router responds with an advertisement that allows the client to make its own address. Now that's the key ingredient of stateless address auto configuration. The client gets to make up his own address. So the word coming back to it in this let me point it out, in this router advertisement is, I'm going to give you, the router says, I'm going to give you the information you need, the prefix length, oh, and some other information. And we'll be talking about that. And it sends it to all nodes in a multicast. Remember in IPv4, the response from the router was a unicast. Now we're seeing it in a multicast. Okay, so I'm going to take you through a look at this one operation, the Slack operation. And the thing you have to remember, or you have to know, is it has to be enabled on the router in order for this to work. And you do that with this simple command. So there's the command that gets put on the router, right? You got to enable the router to do this, okay? So here's the setup then. The client starts, says, hey, I need an advertisement. He sends it to all the routers, okay, as a multicast, right? So many more. There could be other paths, right, coming off of this router. It could be part of a network. So it's being sent out to quite a few. The response is, I'm going to send you a prefix length, and whatever else I need to send. Okay, so now the client looks at this and says, I'm going to generate my own interface ID. That means I'm going to make my own IPv address. I've got the information I need, prefix length. So I know prefix means kind of what network or what global area in the IP space, IPv6 space, am I going to get to work with? And I'll use that and any other information that they pass along with me to create my own address. Okay? And then I need to put this out. This thing here is sometimes referred to as the DAD. No, it's a duplicate address detection. So there's a multicast that has to take place to say, basically, hey, does anybody else out there have this address? All right, if you do, let me know, because I don't want to duplicate an address. Back up here, I had two choices for creating my address, right? I can pick one randomly, or I can use a convention, which is a European thing, the EUI-64. And the 64 means I'm going to generate the bottom 64 bits of my complete address, my 128-bit address. The random thing is going to do the same thing also. These are not the same. You use one or the other. Okay, and you can set it up for that, and you can be very specific about how you set that up. So let me take a look then. Let's take a look with you about stateless auto configuration and DHCP in v6, because this leads to a bunch of choices that are going to have to be made. So it starts the same way. The client goes to R1 and now R1, he knows that address, right? He knows G00. So I'm going to R1, it's probably the gateway. I'm going to R1 and solicit an advertisement. Now really then, here's the possibilities, and I indicated these three in the opening slide. Here's the possibilities, right? I briefly discussed this. We're going to go in more detail on this. For Cisco, this is the default. Slack is the default. So use only this advertisement. In stateful DHCP, this is going to look like IPv4. Use the server. So somewhere you got to get in touch with the server. So it gets the server involved. And only the server is going to hand out addresses. So that means they're going to be controlled by a server, right? There's no server in this picture right now. So you got to get one in there somewhere. Maybe R1 can be configured that way, but maybe not. And then there's this combo thing where it uses this this RA, this router advertisement, and it uses something that's stateful. So we're back invoking a server. So in the next ones, we're going to look at these three possibilities coming out of the router. Okay, so we'll be back in lecture 5. This is kind of the setup of how DHCP 6 is used. And they're separated as DHCP and Slack, because Slack is a completely separate way of getting addresses, assigning addresses.